In this video, I'll show you how to secure web applications running on Kubernetes using AWS Certificate Manager and the AWS Load Balancer Controller. By the end, you'll know how to enable HTTPS with a valid TLS certificate and route traffic securely through Traefik. Before we start, let's quickly understand the AWS Load Balancer Controller. It automatically creates and manages AWS Elastic Load Balancers for your Kubernetes services or ingress resources. This means your app can be accessed through a single DNS name or IP address, while the controller handles routing to the right pods inside the cluster. Here's the step-by-step process we'll follow. Deploy a sample web application on Kubernetes. Set up a domain in Route 53. Request a TLS certificate from AWS Certificate Manager. Install Traefik with AWS Load Balancer Controller. Update DNS records to point to the load balancer. Create an ingress route for routing. Finally, access the app securely over HTTPS. We're using a simple Nginx-based web application prepared with Kustomize. You can get the source from the GitHub repository. To deploy it, we apply the dev overlay. This creates a deployment and service in the dev namespace using dev web service. Next, make sure your domain is managed in Route 53. In this example, we're using ServiceFoundry.org, and we'll expose our app at dev.servicefoundry.org. So our DNS must exist inside the Route 53 hosted zone. Now we request a wildcard certificate in AWS Certificate Manager, for example, *.servicefoundry.org. ACM provides a CNAME record that we need to add in Route 53 for domain validation. After validation, the certificate becomes issued. Remember to copy the certificate ARN. We'll use it when installing Traefik. We install Traefik with Helm using a custom values file. In this file, we add annotations to attach the ACM certificate and enable HTTPS on port 443. This YAML snippet configures Traefik to use HTTPS and integrates it with the AWS Load Balancer Controller. Under ports.websecure, Traefik listens on port 443 for HTTPS traffic, but forwards it internally to the web port using plain HTTP. The proxy protocol and forwarded headers set to insecure true allow Traefik to trust headers coming from the AWS Load Balancer. In the service section, Traefik is exposed as a load balancer service. The AWS annotations do the following. AWS Load Balancer SSL cert attaches a TLS certificate from AWS ACM. AWS Load Balancer SSL ports enables SSL/TLS termination on port 443. AWS Load Balancer backend protocol tells AWS to forward traffic to Traefik using TCP. Optionally, you can switch to a network load balancer by enabling AWS Load Balancer type NOR-LB. In summary, this setup enables HTTPS using an ACM certificate on AWS while routing traffic securely to Traefik in Kubernetes. Traefik is deployed in the Traefik namespace, and the AWS Load Balancer Controller automatically provisions a load balancer for it. By default, AWS creates a classic load balancer. If you prefer a network load balancer, just add the AWS Load Balancer type NLB annotation in the Traefik service configuration. Update the values file and reinstall if needed. After Traefik is installed, go to Route 53 and create an alias record. Point dev.servicefoundry.org to the load balancer that was created. Once propagation is complete, traffic will be routed to your Kubernetes cluster. Next, we define an ingress route in the dev namespace. It tells Traefik to route requests for dev.servicefoundry.org to the dev web service on port 80. Apply the YAML file to activate the route. Now open a browser and visit https://dev.servicefoundry.org. You should see the development page and the connection should be secure using a valid TLS certificate from AWS ACM. Important note about load balancers. If you uninstall Traefik, the auto-created load balancer will be deleted as well. If you want to keep it, create it manually or use node port with a static setup. That's it. You've successfully secured a Kubernetes web application using AWS ACM and the AWS Load Balancer Controller. This approach is ideal for AWS environments because it simplifies certificate management, integrates deeply with Route 53 and ACM, and removes the hassle of manual renewals. Thanks for watching. If you found this helpful, please like and subscribe. See you in the next video.